we are on the page 16, section 7.4. Last time we talked about factoring trinomials, right? With leading coefficient is 1 or not 1. With 1, you can do it directly, and with if it's not 1, you have to use AC method. Okay, so that was factoring the trinomials. Now we are going to factor the binomials, two terms, right? Let's review how we did in 152A class, how we will multiply. Last time we say x plus 1 times x plus 2, things like this. Then when you multiply, you have x squared, then 1 times 2 is 2. Don't give me that answer, right? Because you have a middle term as well, is 1 plus 3 is 3x. So it becomes trinomial, right? So today, let's take a look at another situation. If I have, instead of x plus 1 times x plus 2 or minus 2, different numbers, right? But now, if I do that, x times x, x squared, x times negative 1 minus x, do the FOIL, right? Then bottom rainbow, 1 times x plus x, 1 times negative 1, negative 1. When you combine like terms, what happened? The middle part canceled out. So we end up this way. How many terms we have now? 2 terms, right? Binomial. Let's see. If I have x plus 5, x minus 5. So you have what? X squared minus 5x and plus 5x and what? Minus 25. Middle part cancel out. So we have x squared minus 25. Why we have the middle terms canceled out? Because they are the same. One is positive, one is negative. Why we have this situation? Because when we multiply, we have what? Same thing, same numbers, except one is plus, one is minus, right? So if I have x plus y times x minus y, what do you think the answer should be? Should be what? First square minus second square. Is that right? So if I have 2x plus 1 times 2x minus 1, what do you think? First square, 2x times 2x. Don't give me 2x squared. It should be what? 2 times 2 is 4x squared and minus 1 second square, right? So we will have this formula we are talking about is what? We have a plus b times a minus b. We should have what? A squared minus b squared, right? And if we have 5a plus 3b times 5a minus 3b, what do you think you should have? First square would be 25a squared, right? Then minus second square would be what? 3 and 3 is 9b squared, right? Now we are going to do the opposite. That's what we are talking about in this class. We are breaking things down instead of multiplying. So what will we have? So if you have something x squared minus 1, what do you think? It's a first square and second square. You should do the opposite. If it's a minus, that would be x plus 1, x minus 1, right? If you have x squared minus 25, what should you have? If it's both are perfect square, you should have x plus 5, x minus 5, right? If you have, for this one, if you have 25a squared minus 9b squared, 25a squared is what? Perfect square, 5a squared. Then 9b squared is what? 3b squared. Then you should have 5a plus 3b, 5a minus 3b. Is that right? So what we are talking about is when we try to break down a binomial, instead of multiplying, what should we have? If I have a squared minus b squared, if I break down, what should I have? It should have what? If it's a perfect square, it should be a plus b and a minus b, right? That will be your formula. So, and if a squared plus b squared, we cannot break down such as something multiply something. It's a what? A prime polynomial. Because if you have two terms times two terms, either you have trinomial or you have what? Binomial. Right? So you need to pay attention on that. And if you look at the this one, this formula, we call it what? The difference of two squares. Is that right? You have difference of two squares, perfect squares, then you should be able to break down. And if you have a perfect squares, but it's a sum, you cannot break down. That's all you can do. Got idea? Then let's look at some examples. If I have a y squared minus 4/9, how many terms I have? 2. A binomial. Do I have a difference? Yes. Do I have perfect square? Right? Because y squared is y of the square of the y, right? Then 4/9 will be what? 2/3 take a square. So you should break it down as what? Y plus 2/3 or y minus 2/3. You can write a plus b times a minus b, or another way around, a minus b times a plus b. They are the same. 2 times 3 is the same thing as 3 times 2. Then look at the second example. We have difference, right? Do we have a difference of two squares? What do you think? Is x4 a square? Yes, it's x squared square, right? Then y6 is what? Y cube of square, right? Then what should we have? A squared minus b squared should be what? A plus b and a minus b. So for this instance, your a is what? X squared. Your b would be what? Y cubed. That's how you fit in the difference of two squares. If you look at the third one, 4x cubed minus 49x. We have difference, but do we have two squares? X cubed is not a square. X is not a square, so we cannot apply the formula, right? However, remember, we always do what first? Don't forget. You will do GCF first. So what kind of GCF you have for the two terms? That would be x. If you take x out, you will have x squared, right? Take x out, you have 49. Would that be a perfect square? Yes. That would be 2x of squared and what? 7 squared. So what should you do? You have 2x. You break down the difference of 2 squared, one with minus, one with plus. However, if you do that, what did you miss? Don't forget to carry down your x, right? Look the number 4. 49x squared plus 16. We say a squared minus b squared, not a negative a squared plus b squared, right? So one way you can do is you switch them around, right? Method 1. So if you switch them around, you become 16 minus 49x squared, right? Then we have a what? Difference of 2 squares. Then we can do, that's 4 squared. This is what? 7x squared. Whole thing squared, right? So you will have 1 is 4, 1 is what? 7x. You can do that. Or you can have a method 2. Usually we do this way. You take a negative out because we write it in what? Standard form. This one is not a standard form. If I write a standard form from here to here, I will have what? Take a negative out. I will have a 49x squared minus 16. Is that right? Right? So you have perfect square. So you can do what? 1 plus 1 minus, which is what? 7x and 4, 7x and 4. If you do that, you need to carry down your negative. So that will be your answer. For these two, are they the same? Same question, you should get the same answer. Take a look. This one inside, they are all standard form. This one is not standard form. This one is not standard form. If you write this one, right, you will write a 7x plus 4, right, and negative 7x plus 4. Then if we take the negative out here, that would be what? Negative outside, right? This is a 7x plus 4. If you take the negative outside, what do you have? Change the sign, 7x and minus 4. If you write it in standard form, would that be the same? Yes. I think your homework would take either way. Try this. Also try this one. Try this one. See, the computer will take it. But on the test, on the paper, either way, it would be okay. So, if I have this one, which is not on your paper, let's do some more exercise. So, if this one is on your test, right? Not on your paper. So, if I have one like this, 4x squared minus 9y squared, what do you think your answer should be? Do I have a difference of 2 squares? Yes. So plus and minus. This one is what square? 2x. Right? This one is what square? 3y. That's how you would do it. If on your test we have this one, 4x squared plus 9y squared, not a difference of 2 squares, but a sum. We say if it's a sum, what should you have? A prime. You cannot break down anymore. So you would say what? A prime polynomial. Right? If you have x squared minus 16y squared, can you break down to factor it? Write it as a product, right? So, yes, the difference of 2 squares. So that would be your x. That would be 4y squared. 4y, take 4y, total squares. Totally squared, right? So, if I have x squared plus 16y squared, what do you think? You should say it's a prime polynomial. If you have this one, ax squared minus 2. 2 is not perfect square, 8 is not. So you cannot do it. Use the formula, right? However, remember you always have to do what first? So you will do GCF. If you take a GCF out, which is 2, you will have what? X squared minus 1. Can you break down further? Yes. So that will be 2x, right? And 2x plus and minus of what? 1. Don't forget, you need to carry down these 2. If you have similar problem, but it's a sum, same thing, you always do GCF. So you take 2 out, 4x squared plus 1. After this, can you break down further? No. So this is a prime. So your answer will stay here. But you still have to break down the 2. Otherwise, you didn't complete to the smallest units. Are we okay? I'm going to stop here. I'm going to start again. We were doing what? Binomial times binomial. It ends up with what? Binomial, 2 terms, because the middle part cancel out. Now, let's see something else. How many terms I have? 2. But I'm going to multiply what? 3 terms. Let's see what will happen. Same thing, we distribute everything. So x times x, x cubed, 2 terms times 3 terms, you should end up with 6 terms before you simplify it, right? So x times negative x minus x squared, x times 1 plus x. the bottom rainbow, 1 times x squared plus, right? 1 times x minus x, that's negative, then plus 1. 6 terms. However, take a look. What happened to the middle terms? They cancel out. So we will end up what? X cubed plus 1. Right? We have this situation. If I have x minus 1, x squared plus x plus 1. Let's see what's the difference between these two patterns. They are the same except what? This one first started plus, but the middle term for the 3 terms of them trinomial, you have negative. So one is positive, one is negative. That's why the middle part cancel out, right? For this one, what do we have? We have this one, same thing, x squared, this one plus x squared, this one plus x, right? The bottom, this one becomes what? Minus x squared. This one minus x. And last one minus 1. Then what do we have? We cancel out, right? So we have what? X squared minus, x cubed minus 1. That's x cubed. Right? Becomes what? Binomial. 2 terms times 3 terms, it's binomial. Then look at the patterns. One is plus, one is minus. The middle term, they are opposite. The rest of them, they are the same. Right? So, if I have for x plus 2 instead of 1, okay, so this is similar to that. Then I have x squared minus 2x plus 4. It's different now. What do I have? 2 terms times 3 terms, right? We do the same thing. X times x squared, that would be x cubed. X times negative 2x, 2x squared, x times 4 plus 4x, right? Then this one, 2 times x squared, I'm lining up for the same kind of terms, right? So plus 2x squared, this one minus 2 times negative 2x minus 4x, last one 2 times 4 plus 8. Then I cancel out the middle term. What do I have? I still end up with a what? Binomial. Right? Let's look at another one. Minus 2, opposite sign. The rest of them are the same. So when I do that, the first one you multiply them, that will be all the positive, plus 2x squared plus 4x, right? The bottom one is here become minus 2x squared minus 4x minus 8. So same thing, we cancel out, we end up what? Plus 8. Binomial. How come it happens this way? Because the middle part cancel out. However, sometimes we have 2, sometimes we have 4, sometimes we have 1. So the formula is this way. Okay? If either you start from positive or negative. If I have things like this. If I have what? A plus B, right? Then if I multiply something, middle is a negative instead, then this is a positive. First one is what? If I have A squared, right? The middle one would be what? Middle one, see, would be these two multiplied together. The last one is B squared. If I do that, I will end up what? A cubed plus B cubed. Okay, see, for this one, A plus B, B is 2. So first one is A squared, second one is a minus. Minus, you multiply them both. Okay, the last one is what? B squared, this guy squared. So I have a one number and with its square, I end up with what? Cube. That's why we have A squared, B squared here. If I have A minus B, if I multiply A minus B, then if I multiply A squared, right? Then opposite sign in the middle. The middle term is what? These two things multiply together. Then if I multiply another B squared, I will end up what? A cubed minus B cubed. Okay, when we multiply. Now, if we do the opposite, we should have what kind of formula? It's what? If I have A cubed, right, plus B cubed, we are doing the opposite to break down as factors. That means something multiplies something. So we do this way. So plus, so you start AB with plus, right? The inside will be minus. The last one is always plus. Then first term should be what? The first square. Second term should be what? They multiply together A and B. The third term should be what? B squared. That's the formula. You will have some difficulties with this, but practice with it, you'll be okay. If A cubed minus B cubed, what should we do? So if it's a negative, first one is a negative. Second one means inside should be positive. So when you multiply them out, all the middle terms will be cancelled. So this is a plus. So that will be the two terms. Each one is A and B. The first one for trinomial is what? First term squared and plus these two terms multiplied together. And the last one should be the second term, take a square. Got idea? Okay, so we are doing the opposite. So for this one, say x cubed plus 1. So do I have perfect cubes for these two terms? That means what? The sum of two cubes, right? So it's what? AB means x and 1. That's your A, that's your B, right? So we say you will be plus here, minus here, plus always the last one. Then you will be put these two terms together. The back one will be what? First term squared. Second term will be 1 times A times B, so it's x. 1x is x. Then last one will be 1 squared, be 1. Right? The sum of two cubes. If it's a difference of 2 cubes, what should we do? Minus here, plus here, last always plus. So two terms, one is x, one is y, 1. So you do x and 1. That a here is a squared. So it's x squared, right? Plus ab. You multiply these two, x, 1 times x. So the last one is square, 1 square. Is that right? So we are going backwards. How we break down the binomials. For trinomials, you can use AC method. For binomials, you can only use the formulas to decide. Some of them, they are primes. Then if certain patterns, you should be able to break down, right? That one is what? A difference of 2 squares. This one is what? The sum of the 2 cubes. This one is what? The difference of 2 cubes, right? So if we have this one, do I have a difference of 2 cubes? So that's x, take a cube. This one is 2, take a cube. So the formula tells us I should have what? Minus here, plus and plus, right? First one is what? These two numbers. Then this one is x squared, right? The last one is this square, which is 4. That's fine. And you make a mistake in the middle. You will say, oh, these two things together is 2x. Then I take a square, which is incorrect. Remember, that's why we put a parenthesis around. You need to multiply. It's not 2. This one, x squared, 2 is supposed to be 2 times x, right? So be careful when you multiply them. That will be what? 2x. That's correct. Okay, but sometimes you will have a different situation. Then you will make a mistake here. Let's talk about that later. Okay, so if I x cubed plus 8, do I have the sum of 2 cubes? Yes, x and 2. So I have plus here, minus here, plus here, right? So that will be your a and b, x and 2. This one will be what? X squared. Then middle term will be what? 2x. Last term is 2 squared is 4. So that's this case. Did we get back how we multiply them? Right? So we just did what? Factoring binomials, special products. Certain things we can do it if it's what? The difference of 2 squares or the sum of the 2 cubes and the difference of 2 cubes. So let's take a look at your examples on the page 17. First one, y cubed minus 27. Do I have 2 perfect cubes? Yes, it's a difference between them, right? So this one is what? The y takes cube. This one is what? 3 takes cube. So we say formula is telling you what do you do? Negative, so you put a negative here, positive here, right? So that's your y and 3. So you feed in your a and b, y and 3. And second one is what? A squared. So y take a square, y squared. Then second term is what? Multiply them together, 3 and y, so you have 3y. And third one, is this square, 3 squared. But don't leave the answer there because you need to spell it out your number. So you should write your answer this way. Y minus 3, y squared plus 3y plus 9. Are we okay? Looks the second one. So we have 64x cubed plus 1. Do we have perfect cubes? The sum of 2 cubes, right? So you should write it this way. The sign would be what? Plus here, so you have plus here, minus here, and plus here, right? So 64x cubed is what kind of things? Taking cube. 64 is 4, this is x. They take a cube, right? So 1 is 1 cube. So what do? You fit in a plus b, right? Then you take square here. Then if you write 4x squared, let's see what will happen. Then the middle part is what? You multiply them together, 4x times 1, right? The last part is 1 take a square. However, if you write the first one, 4x squared, it's incorrect. Why? Because if you do that, 4 times 4 is 16. We'll not get back to 64. So we say the formula is what? You need to put a parenthesis. Whole thing is a parenthesis. Whole thing, all the a itself has to take b squared. So you need to write a 4x squared here. That's why we use parentheses to make sure we have correct number, right? So your answer should be spelled out. 4x squared would be what? Actually, it's 16x squared, right? Minus 16x, oops, not 16 anymore here. Should be 4x plus 1. That would be your answer. That's where you usually make mistakes. Okay, let's look at the number 3. 54a cubed minus 16b cubed. Those are perfect squares. We think it's a perfect cube, right? A cube, b cube. But is a 54 perfect cube? Not really. 3 times 3 times 3, 81. 2 times 2 times 2 is 4. So we cannot do 54, nor the 16, right? But we say, what should we do first? Always, you need to take our GCF, which is what? Between 54 and 16? That would be 2. After you take out the 2, see what you have. That would be 27a cubed. Yeah, 3 times 3 times 3 is 27, not 81. Never mind. Okay, what I was thinking. Okay, so do we have perfect cubes now? So this one is what? 3a take a cube, right? This one 2b take a cube. Then we say, what should we have? We should have, right? Plus, oh, it's minus. You should have minus here, plus here, plus here, right? So you put your first number here, 3a to b. That's correct. But here, you need to take what? First number, take square. If you write this square, it's incorrect, right? We need to write what? The parenthesis. Right? Then next one, you should have what? 3a times 2b, right? First times second. The third one, you should have not write, don't write it that way, 2b squared, because we need to do what? Whole thing take square, right? So you actually what you should have is 3a times 2b, then 3a squared is what? 9a squared, right? So that should be that one. 3a times 2b, you should write what? 6ab. And 2b squared, that would be what? 4b squared, right? At the same time, don't forget, you need to what? Carry down your 2 as well. So that would be your final answer. What do you need to do? So let's summarize what did we do, what we did, right? Take a look. We are doing what? Factoring binomial, a special product. Either what? The difference of two squares or the sum of the two cubes or the difference of two cubes. So in general, what do? Don't forget, you always do what first? You always factoring out the GCF if you can, if any, right? Then what do? It's binomials. It's not like trinomials. You can do AC method and grouping. You find the answer. You have to rely on what? The formulas, okay? So if it's trinomial, then you can decide what do? You will using the AC method, right? But if it's binomials, what do you need to do? You need to use the formulas. There is no other choice you can have. You just have to remember all those formulas. For this class, we'll let you use the notes to do all that. 152B class. However, if you go to 154A class, the most of teachers will not let you use notes. So you need to remember all those. By practicing your homework, you'll be okay. So that's on page 17. We just finished the what? Section 7.4 for factoring binomials for the special products, special things.